Scanning electron microscope. Scanning electron microscope, also known as SEM. What is scanning electron microscope? Scanning electron microscope (SEM) is a type of electron microscope that produces image of a sample by scanning it with a focus beam of electrons. Specimens can be observed in high vacuum, low vacuum, and in environmental SEM specimens can be observed in wet conditions. Second, the most common mode of detection by the SEM is by the secondary electrons emitted by atom excited, which is by the electron beams. Third, the number of secondary electrons of SEM is functions of the angle between surface and the beam. Fourth, when on a flat surface, the plumb of secondary electrons is mostly contained by samples, but when on a tilt surface, the plumb is partially exposed and more electrons are emitted. And fifth, an image display, the tilt of the surface is created by scanning the samples and detecting the secondary electrons.
So with me, you're gonna learn about how scanning electron microscope works. So first of all, we're gonna look what are the external components of SEM. First, it consists of column for electron beam generation, next specimen chamber, vacuum pump, control panel, and last but not least is monitor. Next, we will learn about SEM operation. What are the internal components of SEM? A scanning electron microscope consists in an electron source, electromagnetic lens, and electron detector. It uses an electron beam instead of light based on wave particle duality. The electron beam is accelerated and focused on a sample using the lenses. The sample emits secondary electrons which are then detected. The number of detected electrons depends on the variation of the sample surface. By scanning the beam and detecting the variation of the number of emitted electrons, one can constitute the surface topography. The electron beam can also ionize the atoms and make them emit X-ray. The ray energy depends on the elementary composition of the sample. By scanning once again the beam and detecting the X-ray energy, one can deduce the chemical nature of the material and its spatial variation. Other types of interaction between the beam and the surface allow to perform various complementary analyses. The scanning electron microscope (SEM) does allow to obtain a magnified image of the surface of the sample and to analyze their composition. What happened in detail shows a schematic drawn atom from near the surface. Just like any other atom, it consists of positively charged nucleus and negatively charged electron. The electron stays in genetically well-defined wall around the nucleus. A primary electron comes from above and accidentally knock out electron from the case shell of the sample. A vacant place remains as indicated as yellow circle. This state is called unstable. An electron from L shell fills the gap and the energy difference is released in form of characteristic photon. This extra photon is so-called characteristic because the energy is quite characteristic and typical for element. Now another transition follows and finally the atom repairs itself with an electron from vicinity. So X-ray generated during the operation of scanning electron microscope, namely X radiation, which is characteristic for the chemical element present in the sample. If the energy and intensity of radiation are measured with an X-ray detector, then the chemical composition of sample can be determined. Every instrument has its advantage and limitations. So what are the advantages of SEM? From scanning electron microscope, we could get a 3D topography image of sample. Scanning speed of scanning electron microscope is high as it completes secondary electron imaging in less than 5 minutes. Modern scanning electron microscope also allow generation of data in digital form. It is very important research tool in the field of biology, medical, and forensic science. So next, we're gonna look about what are the disadvantages of SEM. The first disadvantage of scanning electron microscope is the size of SEM is very large. Special training is required to operate SEM. There is a risk of radiation exposure with electrons that scatter from the need of sample surface. SEM can only scan solid and inorganic compound.
Type of signal produced by SEM: secondary electron, backscatter electron, characteristic X-rays, light photoluminescence, CL, specimen current, transmitted electron. Secondary electron. Secondary electron detectors are standard equipment in all SEMs, but it is rare that a single machine would have detectors for all possible signals. This video shows the positioning and the operation on a secondary electron detector in the SEM chamber. The signal results from interaction of the electron beam with atom at or near the surface. In the most common or standard detection mode, secondary electron imaging, the SEM can produce very high resolution images of a sample surface revealing details less than 1 nanometer in size. Due to the very narrow electron beam, SEM micrographs have a large depth of field yielding a characteristic 3D appearance useful for understanding the surface structure of a sample. Backscatter electron is a beam electrons that are reflected from the sample by elastic scattering. BSE are often used in analytical SEM along with the spectra made from the characteristic X-rays because the intensity of the BSE signal is strongly related to the atomic number Z of the specimen. BSE images can provide information about the distribution of different elements in the sample. Characteristic X-rays. Characteristic X-rays are emitted when the electron beam removes an inner shell electron from the sample, causing a higher energy electron to fill the shell and release energy. For the procedure, sample will be coated with a thin layer of conductive material. It is done using a device called a photocoater. Sample will be placed in a small chamber that is at a vacuum. Gold foil is placed in the instrument. Argon gas and an electric field cause an electron to be removed from the argon, making the atom negatively charged. The argon ion then become attracted to a negatively charged gold foil. The argon ion